All right. Good afternoon, folks. Welcome back. It was good. It's nice to get a chance to see everyone yesterday. Hopefully, you had a chance to watch the video and work through some of those problems. I appreciate the feedback that a few of you gave me in regard to the information what we've been doing in class so far, and that's very helpful for me. I think it's difficult for me to kind of get a sense of how you guys are doing. So I look forward to our meetings. That way, I can get some feedback from you. Please make sure you understand that I'm available every day after school from 1:30 to 2:30 for office hours, or you can email me. I'm available for your concerns and also your questions. And so, if you have some concerns about the material that we're covering, the what we're doing in class, please make sure you come by and you let me know, or email me, let me know. I use that feedback. I use that feedback to get a sense of what we can do, what's possible, and especially at this moment in time and what we've been experiencing. It's we don't get to meet every day in class, and even then, I have some difficulty trying to get you to give me some feedback, but I use that feedback to help me. Okay, so yesterday I got feedback from a couple of you about the material that we've been covering and the difficulty that you've been having with it. And so what we're going to do then is, because of that feedback, I'm going to leave out the last portion of the unit the kinematics unit that we started a few weeks back. Okay? And so we won't do that. So I'm going to finish up today with just work through a few more of these free fall problems, and I'm going to leave out projectile motion. And so we will not cover projectile motion in this class here. Just so you don't have to worry about the last part of the lecture notes here. So what I would like to do then to switch things up a little bit is that I want to work through these. There's a couple of last problems for you for us to do involving the free fall. I'll work through the last few of these problems here. And what I would like to do with the last two periods, the remainder of this week then, is that tomorrow I won't conduct class. We won't have class, but I want you to use that time to get the work done. So I'm going to post, and I apologize that it's been a little bit more labor intensive than I thought it would be. I'll post some practice problems for you to do. And what I would like you to do is tomorrow during class time, instead of watching another video, okay, what I'd like you to do is take that class time to work through those problems, work through the kinematics problems, work through as many as you can, and pick one or two problems that you have questions about. What I'd like you to do then is on Thursday. So Thursday and Friday, Thursday and Friday. Remember, Friday we're meeting, so don't forget that. Friday we're gonna meet. What I'd like you to do then on Wednesday, and I'll post it for you before 11:59 Wednesday night. I would like you to type in the questions that you had from the assignment that I gave you. So I'll post the assignment tonight. Okay, I'll post the assignment tonight. And what I like to do is work on it on Wednesday. So tomorrow, instead of having class, I want you to work on the assignment. Okay. And then at the end of that assignment, and make sure you get it done before 11:59 tomorrow night. Okay, I want you to type in two questions. You have to. Each person must type in one question to get credit for credit for work and for the period tomorrow. So you have to. That's a requirement. And I'll post those. I'll post the requirements for you tomorrow this afternoon when I post the assignment. But you have to post two. You can post as many questions you want, but I want you to post at least one question from the assignment that you had trouble with. Okay. And then what I'll do then is I will make a video. I will answer all those questions on the video, and then you can watch it on Thursday. And then that way is then Friday. From Friday, then you can go ahead. We'll meet, and you can ask more of your questions. Okay. Now understand that you're not limited to just the questions asked tomorrow night. You can come by tomorrow after school at 1:30, 2:30 and ask your questions then. You can ask your questions Thursday after school, and you can ask your questions on Friday. But what I am requiring you to do tomorrow is that I want you to work through the assignment. So again, I will post the assignment tonight. You'll work on it tomorrow in class. So no video tomorrow. Okay, we're not going to meet live, but just going to work on it, work on the assignment independently. And then by the end of tomorrow night, by 11:59 tomorrow night, I want at least one question from each one of you from the assignment that I can use to work out. So I'm just going to work out those problems. And so then on Thursday, you'll watch the videos. Hopefully we'll get, you'll see your question there. You'll see that question answered. And then you'll see what other people asked as well. And I'll work through those problems for you. So that's what I'd like to do moving forward. Instead of introducing something new with projectile motion, overwhelming with that, we're gonna stop here. And I want you to focus in on the kinematics chapter, the kinematics section here, kinematics section, and work on these problems here. And so work on those problems and pick a problem and ask about it, and then I'll work it out for you on Thursday. Friday, then we'll meet, and you can we'll meet live, and you can ask your questions at that point as well. Okay. But again, don't feel that you are obligated to wait until Friday to come by and ask questions. You can come by this afternoon. You can come by tomorrow afternoon, Thursday afternoon, and then on Friday as well. Okay. All right. So with that said, then let's go ahead and let's finish up a few of these problems here that we worked out. Okay. So we left off with this problem yesterday. Okay. This problem here was the problem involving the coin toss. Remember, so we had a coin toss problem, and I had pointed out to you then that we worked out the first half of this problem here, and with this first problem here, we were examining a coin that's being just tossed straight up. We're told that the coin traveled the total distance of 0.25 meters. It's in one direction, and so therefore we can call that the displacement as well. The displacement is positive here, and it moves up to a height of 0.25 meters. Remember, if this is the third case of the free fall, where the object moves up and then comes back down, remember the third case of the free fall is an object being tossed up. So this is a coin being tossed up. That means then that the velocity at the very top here is going to be 0 meters per second. Okay, so that was the problem, and in that particular problem, we were asked to find the initial velocity, the velocity of the coin as it leaves the hand, and we were able to calculate for that as being 0.22 meters per second. Okay. Then the problem that we were started on yesterday, before we finished up, involved then the coin then going up and then moving back down. So in that particular problem, we are examining the upward trajectory and the downward trajectory as well. Okay. And the question there was asking us then, based on the upward and then the downward motion, the full complete motion, how much time did the coin spend up in the air? Okay. And so with that said then, the motion here represents a symmetrical motion, and we talked about this, that whenever you have an object that's moving in that is undergoing the third case of the free fall, if the motion is symmetrical, there are certain characteristics about that motion that we can use to help us solve for this. Okay, and the first one is that the time interval that it takes to go up to the very top there is going to be equal to the time interval that it goes down. So we said then that these two time intervals are equal to one another. So therefore, let's go and write this in. The time up is going to be equal to the time that it takes to go down. And we know that. So therefore, if we can calculate for the time up, we know what the time down is. Okay, so when we have an object moving in the third case of the free fall, that it moves up and that is being tossed up, the time it takes to get to the very top is going to be equal to the time it takes to go down. Okay, which means then, if you want to, and we're kind of trying to find the total time here, which means then the total time that it spends in the air is going to be time up plus time down. Okay, and if those two are equal, folks, the total time then is going to be equal, essentially, if you want to think about it, double the time it takes to go up. So if we can find the time it takes to go up, or conversely, we can do it all. So if we can find the time it takes to get back down, okay, we double that, we will get the total time. Okay, so that's what we know there. Okay, and so let's say then, so we have the opportunity to find that, and we'll go ahead and do that. But let's say then, so let's go ahead then and let's work this out. Okay, so this is the free fall. So as a free fall, we know then that this is always going to be true, regardless of what type of free fall it is. We know that that's always going to be true, and that is the acceleration is constant. Okay, and that acceleration has a value of negative 9.8 meters per second squared. Let's go ahead then, if we're going to solve for time, let's go ahead and write down the kinematic equations that we have at our disposal in order to get that done. Okay, so we have then V final, it's going to be equal to V initial plus acceleration times time. Now, if you're worried about memorizing these here, on the exam next week, I will give you these equations. I will give you these formulas. I did ask you to memorize them. I did suggest that you memorize them, because in memorizing them, it just makes the work go by a little bit faster. Okay? But if you have a hard time memorizing them, if you're worried about it, I will give you these formulas next week. Okay, so you need to make sure then you figure out which formula you're going to use. Okay, so that's the first kinematic equation. Okay, second kinematic equation then will give us the displacement, which is V times time plus 1/2 a t squared, and then the last one then is going to be V final squared equal to v initial squared plus 2 acceleration times displacement. Okay. All right, so those are the three kinematic equations that we're going to make use of. Okay, those are the three kinematic equations that we will choose from to solve for. In this case, then the time it takes to go up. So again, we're going to find the time that it takes to go up. Okay, so we need the time it takes to go up. If we get that, we double it, we will get the total time. Okay, so looking at the first equation here, we have time right there, folks. Time is right there. So the question we have to ask then is, if we want to solve for time here, do we have v final? Well, yes. If we are looking at the upward movement here, folks, if we're looking at the upward trajectory, v final then represents the position right here when it comes to a stop. So we do have that v final. Do we have v initial? Absolutely. V initial we solved for back in the problem previously. Okay, so we have the v initial here, and then finally, do we have acceleration? Yes, because this is free fall. The acceleration is given to us, so we can absolutely use that equation to solve for it. So let's go ahead and let's use that equation to solve for it, rearranging this equation here to solve for time. Okay, rearranging that equation to solve for time, then it's going to be v final minus v initial, all divided by the acceleration. Okay. All right, so let's go ahead and plug in those values for us. Okay, so v final then is going to be 0. Remember, v final is going to be here because we're saying then that if we're only looking at the upward motion, so if we're only examining the upward motion, it stops its upward motion right here. So where it stops here, that's your v final. So that's going to be 0 meters per second minus v initial, which we solved here, is going to be 2.2 meters per second. Okay, all over the acceleration, which is negative 9.8 meters per second squared. Okay, you plug in those values in. You plug in those values, and you get a time then of 0.22 seconds. Okay. So this, remember, is the time it takes to go up to the very top of that pathway. It takes time to go up to the very top of that pathway. And so like we said then, once we have that, we're not done at this point, folks. Once we have that, to find the total time, we need to take this time interval here, and then we double it. Okay, so we're going to take 0.22, we're going to double it. And so therefore, the time interval it takes to go up and then come back down is 0.44 seconds. And that, folks, is our final answer. Okay. All right. So with that said, then we use the upward trajectory here to find then this time. Let's say then what happens if we use the downward trajectory? Let's say, remember, I told you because time up is equal to time down. We said that here, which means that in this equation here, then we could have doubled the time it takes to go down in order to solve for the total time as well. How would we solve for the time it takes to fall back down from the very top here? Okay. Well, if we're examining the downward trajectory, folks, we can still use this equation here. Okay, if you take a look at it, this time though, we have to identify what v final is, and v initial, the acceleration is still negative 9.8 meters per second. The question is, what is v initial and what's going to be v final for the downward trajectory? To answer that question, you have to understand then that if we're looking at the downward trajectory, the starting point then is here. That means then this velocity right here at the height represents the initial velocity. Okay, and so the question then is, what's going to be the final velocity when it gets back down to this position? Okay, so we're looking at the downward trajectory here. So what is the final velocity? Well, to answer that question, that we have to we have to say that the final characteristic of the symmetrical motion, then remember, is that v final then is going to be equal to the initial velocity, but in the opposite direction. Which means then, if v initial is 2.2 meters per second, v final at this point here is going to be minus 2.2 meters per second. Okay. Now you have to understand this. Okay, this v final here is not the same v final that we used right here. Remember, this v final is a result of us looking at this upward motion. Okay, so as it moves up, it's going to stop right here. And again, what we're doing is, you can imagine, we're looking at only upward motion, and so this is a film of it. We would pause it right here as it reaches the top. So the velocity at the very top there, and the upward motion represents the final velocity. The initial velocity is what it starts out with here. But if we're looking at the downward motion, okay, if we're only looking at that, ignoring the other half, then as it moves down, this is where it starts out. The starting point in its downward motion is at the very top here, and then it ends up at this point right here. So when we examine the downward motion, this velocity represents the initial velocity. And then here, based on what we know about symmetrical motion, we can say then that the final velocity is going to be the initial velocity here on this side, on the upward trajectory, but in the negative direction. Okay, so let's go ahead then and let's plug it in. Now I'm going to go ahead and do that for you really quickly. Plug it in, okay, and let's solve for the time again. Okay, so this time it's going to be time it takes to go down. Okay, and I'm just going to plug in the values here. You already have the equation here. We're just going to substitute for this. V final then is going to be negative 2.2 meters per second minus V, and this minus V initially, which is going to be 0 meters per second, all divided by negative 9.8 meters per second squared. And sure enough, what do you notice? The time here is exactly the same, 0.22 seconds. That takes 0.22 seconds to come back down, which is what we said. The time up versus the time down should be exactly the same, and we see that right here. This is the time it takes to go up. This is the time it takes to go down, and they're exactly equal. So therefore, then, if you imagine if we had solved for the time down, we double it, and then we get the total time again as 0.44 seconds. Okay. All right. So with that said, then I hope that you can see then that the symmetrical motion is not going to be difficult. It's pretty straightforward, and it's not going to be very difficult. Okay. What I would like you to do then, and I'm not going to require it right now. We're going to move on. Okay. But we see that here, this equation also has time in it. Okay. This equation has time in it as well. It has time here and time here. Could we use this equation then to solve for time? The answer there is yes. The answer there is yes, because we have the displacement, that's 0.25. This velocity here can be considered then the initial velocity, so we look at the time it takes to go up, okay? So therefore, the initial velocity here is 0.22 meters per second, okay? 0.22 meters per second, that's what it starts with. And then we have acceleration is negative 9.8. The only problem that you're gonna have here to solve for time then is this is an exponent here. This is a square, which means then what you're gonna have to do then is you're gonna have to use the quadratic equation to solve for this, and that's not a very pleasant thing to do. Okay, so like I pointed out to you, when you solve for these problems here, try to pick the equation, try to pick the formula then that's going to give you the easiest solution. Okay, there are going to be multiple solutions to this, folks. As you progress on with the physics and you revisit this again, there will always be multiple solutions to this. The only problem then is that one solution will be easy, the other solution will be more difficult. So always go with the easier of the 2 or 3 solutions, and that just makes life easier for you. Okay. All right. Very good. Let's go ahead then, and let me go ahead and let's continue on, and let's talk about the. Let's do one more problem here. What I'd like you to do is take about 5 minutes, okay, to work through this problem here. Take about 5 minutes to work through this problem, and then I'm going to start this problem for you. And then we'll I'll ask you to just submit the work for you. So this problem here, you're asked to find the velocities and position of a golf ball that is released from rest. So make sure you can identify what type of free fall it is. And the problem wants you to find the velocities and position at 3 time intervals: 1 second, 2 second time interval, and 3 second time interval. Okay, so please make sure you work through this one here. Okay, take a little bit of time to work through this, and then I want to work it out with you. Okay, so take about 5 minutes. Okay, let's go ahead and let's take a look at this problem here, folks. And like I said, I want to work. I'm not going to work out all of it for you. I want you to take a look at what you have here. Okay, but let's go ahead then and let's draw what we have first of all. So first of all, my hope is that everyone was able to see then that this is the first case of the free fall where an object is being dropped. Okay, so we have then our golf ball here, and the golf ball then is being dropped. It is being dropped in the downward direction. Okay, so it's undergoing a free fall here, and so we have that. So this is the first case of the free fall, which means then the initial velocity here, the initial velocity, because it's dropped from rest and it's a third case of free fall, that initial velocity is going to be 0. Since this is a free fall, we know what the acceleration is. The acceleration is always going to be a constant, okay, and that constant has a value of negative 9.8 meters per second squared. Okay. And so what they want us to do then is they want us to examine then let's go ahead and I'm going to draw some dashes here. Okay. The velocities and position at 3 different time intervals. Okay. So I'm going to divide this motion up into 3 divisions. Okay. Each division then representing a time interval. So this represents time is equal to 0 seconds, okay, when it starts. This then will represent the time at 1 second. This is the time at 2 seconds. And then finally, this will represent, this last division here represents the time at 3 seconds. Okay? So you can imagine we take a stopwatch, stop it at 1 second, stop it at 2 seconds, stop it at 3 seconds right there. And at each time interval, what they want us to do then is they want us to find the velocity. So this is then, this would represent velocity final then. They want us to find the velocity, and they want us to find the displacement, okay, how far the object has dropped. Okay, so they want us to find the displacement, velocity, okay, at each time interval. Okay, and so what I'm going to do then is I'm going to work through the first two for you. I'm going to work through, and I'll call this VF1, delta Y1, VF2, delta Y2, VF, I'm sorry, that looks a little messy there. Okay, and I'll find then VF3 and delta Y3 for you, and then I'll leave it up to you to determine then whether you figured this out correctly or not. Okay. All right, so this problem ends up being a whole lot simpler than what we did in the previous problem. Okay, so what we're going to do then is we're going to pick the correct kinematic equation here. So again, I'm going to write it out for you. So we have V final equal to V initial plus A times T. But instead of you writing it out, make sure then you just have it memorized. Okay, or you make sure you have then the flashcard in front of you. Okay, V times T plus 1/2 A T squared. And then finally then, V final squared is going to be equal to V initial squared plus 2A delta Y. Okay. All right. So we have a choice between those three. Okay. And so let's take a look at this. We want to find then V final, and we want to find then delta Y. Okay. So let's take a look at what we have here. Let's take a look at V final first. Okay. To solve for V final here, this equation has V final, equation number 1, and equation number 3 has V final. Okay? But let's go ahead and let's consider this first. Do we have V initial? If we want to use equation number 1, do we have V initial? Yes, we do. We have it right here. Do we have acceleration? Yes, we do. We have it right here. And do we have time? Yes, we do. We have times listed here. So if we're going to solve for this first one here, we're going to solve for V final 1. We can absolutely use equation number 1 here. Could we use equation number 2? Sure. Do we have the velocity initial here? Yes, we do. Do we have the acceleration? Yes, we do. Do we have displacement? Not quite yet. If we can find this displacement, folks, then we can go ahead and use this here. Okay, so we need to get that displacement if we want to use this. So for right now, the easiest way to go about doing solving for V final here is to solve for that first equation. Use that first equation. Let's go ahead and do that. Okay, so V final at time 1 second. It's going to be then V initial plus A times T. Okay, so therefore, let's go and plug it in. V initial is going to be 0 meters per second plus negative 9.8 meters per second squared. And the time interval here is 1 second. It's a 1 second time interval. Okay, and so we plug that in then. V final at this particular position then is going to be negative 9.8 meters per second. That's V final for time interval number 1. Okay. How about delta Y? So let's go ahead with that said then. Can we solve for the change of position at that point? Well, let's take a look at what we have here. Okay. So let's take a look at what we have here. Which equations has displacement in it? Well, this equation number 2 has displacement in it, but in order to use it, can we identify V initial here? Yes, we have it. Okay, so V initial here, that constant velocity, and remember, this is the velocity before acceleration. Okay, so we have that right here. We have that at 0. Do we have the acceleration? Yes, we have it here. And then do we have time? Yes, we have it right here. Okay. Could we use this to solve for displacement? That question then is, do we have V final squared? Do we have V final? We just solve for it right here. Do we have V initial? Yes, we do. We have it right here. Do we have acceleration? Yes, we have it right here. So we can also use this equation to solve for it. Now it comes down to the question, which one's going to be easier? I think for me right now, it's going to look like this is going to be a little bit easier here to use to solve for. So I'm going to go ahead and use it. Okay. Now it's not that much more difficult to use this one. If you can go ahead and work it out, but you should get the same answer. Okay. All right. I'm going to choose this one because this already has delta Y set up for us. Okay. So that means that we need V initial. That is the acceleration, the velocity before. That's your constant velocity plus 1/2 A t squared. Okay, so let's go ahead and plug in our values here to solve for delta y1. V initial then is going to be 0 meters per second times 1 second plus 1/2 negative 9.8 meters per second squared times 1.00 seconds squared. Okay. All right. So you plug that in, then this becomes 0. You take 1 squared is 1. Take a half 9.8. You get then negative 4.9 meters. And there it is. So at this position here, when the golf ball is dropped at this position here, it will have a speed of negative 9.8 meters per second, and it's moving in the downward direction. And it will have moved, once it gets to 1 second here, a distance of 4.9 meters below your start. So it's moving in the negative direction as well. So that's what we have there. Okay. So that means then, if we take a look at V final 2, let's go ahead and solve for that one. V final 2 then, folks, we can use this exact same equation here, this exact same method to solve for it. Okay. And the only thing we'll change then is this time interval right here. Okay. Because V initial, and we're going to start from here, will still be 0 meters per second. The acceleration will still be negative 9.8 meters per second squared. But this time, the time interval is going to be 2 seconds, because we're talking about this time interval here. So we're doing the exact same thing in order to solve for this V final here. And so you plug that in, then you will see then that V final at the time interval at t equals 2 seconds is going to be negative 19.6 meters per second. And that's what we have right there. And we can do the exact same thing with the displacement at 2 seconds then, is we'll use the exact same formula, okay, using the exact same initial starting point. Okay. And so therefore then, this will be 0 meters per second. This time, the only thing that changes again is the time interval, which is 2 seconds, plus 1/2 negative 9.8 meters per second squared. This time then, it's going to be 2 seconds, and we're going to square that. Okay, so this is going to be 0 again. This is going to be 4 times negative 9.8 times 1/2. We have then here negative 9.8 meters. Okay. Okay. And we can plug it in that way. Okay. All right. So what I'd like you to do then is go ahead and finish up the third one. So go ahead and confirm the third, the final velocity for time interval number 3. Go ahead and get that done, and then compare that to the displacement at time interval 3 as well. And you're going to notice you're going to use the exact same 2 equations as well to get this done. Okay. All right. So with that said, then I'll post a set of practice problems for you this afternoon, this evening. Work on it tomorrow in class. So again, we no video for tomorrow. I just ask you to work in class, use that time to work out work out the packet. And remember, by tomorrow night, make sure you post at least 1 question from the practice problems so that I can work out for you. And then you'll watch the video of me working out the problems for you on Thursday. And then on Friday we'll meet and we'll take live questions at that time. Okay. All right, folks, very good. I will see you on, we'll meet again. I'll have a recorded video for you again on Thursday, and then I will see you folks on Friday. Okay? Have a good day. I'll see you.